Section 7.6 is talking about a normal line of a linear equation. We've had normal lines before in geometry. I know because I taught you in that class. But a normal line is a line that is perpendicular to another line, curve, or surface. The normal form of the equation of a line is written in terms of the length of the normal from the line to the origin. All right, so what it's saying is any line or curve or anything like that, its normal line. So say I have a line like this. A normal line is any line that is perpendicular to that line there. So this line here is the normal to this line here. Okay. Normal form is in the form of x cosine of theta plus y sine of theta minus p. All right, why is the cosine with the x? Well, we talked about that, especially in your unit circle. Your unit circle, you're given like 30 degrees, and they gave you an ordered pair of square root of 3 over 2 and 1/2. Well, we said that the cosine value was the x value and the sine value is the y value, and we also talked about how the cosine value, the adjacent side is always the x-axis and the opposite side is always the y-axis. Hence, that's why sine is the y and cosine is the x. So those are ways for you to remember this equation. Plus y sine theta minus p, where p is the length of the normal from the line to the origin, and theta is the positive angle formed by the positive x-axis in the normal. All right, so as they say, they've given us an angle of 30 degrees from our x-axis to the normal line. So an angle of 30 degrees, and that's where our normal line is, and it's normal to maybe this line here, something like that. Okay. So here, example 1 is changing from normal form to standard form of equation. Remember, standard form of equation is this: ax plus by plus c equals 0. That's standard form of equation of a line right there. Remember where a is always positive and we don't have any denominators, we don't have any fractions. We just get rid of the denominators at the end. So example here says write the standard form of equation of a line for which the length of the normal is 3 units and the normal makes an angle 60 degrees with the positive x-axis. Okay, so they give us two things here. They give us theta and they give us p. All right, that's the length of our normal here. All right, so all we do is we plug that in. So we say x cosine of 60 degrees plus y sine of 60 degrees minus 3 equals 0. And now we just got to change that to get it to standard form, which is fairly simple. We are just going to take the cosine of 60 degrees to get rid of our cosines. The cosine of 60 degrees, we can draw this out just to be sure. Use our 30, 60, 90 triangle. This is 60 degrees. That means this is square root of 3. That means this is 2. That means it's 1. The cosine of 60 is 1 all over 2, so 1/2. So we have 1/2 x plus the sine of 60 degrees is square root of 3 over 2 y minus 3 equals 0. And then we said in standard form we didn't have any fractions. To get rid of these fractions, if we multiply every single thing by 2, we get rid of our fractions. So that means we have x plus the square root of 3y minus 6 equals 0, and we're done. Easy enough, right? And then we can graph this line here. Pick a value for x, solve for y. You can plot it on the ordered pair or on an xy coordinate plane. So that's that example right there. I think I have another example just like it. We can do it just to be sure that we know what we're doing. Write the standard form of the equation for the length of the normal p is 8 units, and the normal makes an angle 45 degrees with the x-axis. So we say it's x cosine of 45 plus y sine of 45 minus 8 equals 0. All right, well, the cosine of 45 is square root of 2 over 2. Plus the sine of 45 is also square root of 2 over 2. And again, we don't like fractions, so it's going to be the square root of 2 x plus the square root of 2y minus 16 equals 0. And all I did in this step right here is I multiplied everything by 2 times 2 times 2 to get rid of that fraction. Okay? All right. Now we're going to be changing from standard form to normal form. So say we want to know the normal line and the one that's perpendicular to this line here that they give us can a lot of times be helpful in construction and stuff like that. The standard form of a linear equation ax plus by plus c can be changed to normal form by dividing each term by plus or minus the square root of a squared plus b squared. So all that means is you're taking the number in front of the x and the number in front of the y, you're squaring them, taking the square root. All right. And then we have it's either positive or negative. That sign is chosen by the opposite sign of c. So if this is a plus, this is a minus. Or sorry, so my bad. If this is a plus, this is a plus. My bad. If this is a minus, that's a minus. My fault. Or no, sorry, I was right. Man, opposite sign. If this is a plus, that's a minus. If this is a minus, that's a plus. The opposite sign of C. Wow, holy cow. All right, so here we go. Let's write the equation 2x minus 5y plus 3 in normal form. Then find the length of the normal and the angle it makes with the positive x-axis. Okay. So we're going to divide each term here by, let's see, it's going to be negative square root of 2 squared plus negative 5 squared. So here I'm going to get 4 plus 29, so I have the square root, I have negative square root of 29. So I'm going to divide each term by negative square root of 29. All right, so I have 2x divided by negative square root of 29 minus 5x divided by negative square root of 29 plus 3 all over this negative square root of 29 equals 0 divided by the square root of 29, which is just square root of 29. So here's our normal form. This just got it right away in the normal form of an equation. They want to know what the length of the normal line is. Well, that's just p. So our length of our normal line here is always a positive distance. It has a distance of 3 all over the square root of 29. The negative just indicates the direction in which it's going. All right, and then they want to know the angle. Well, we know two things here. We know that typically, if we were going from normal to standard, we would say it's cosine of x times x plus y times the sine of theta. Sorry, I shouldn't use x's in there. Sine of theta minus p equals 0. Well, I noticed one mistake. It's typically minus p. Since this is a plus p, negative p, that switches that sign. So, sorry, p equals 3 over the square root of 29, not negative. All right, so that's typically a minus. So that's why that's a positive 3 square root of 29. I messed up there. Sorry about that. Good thing I wrote that out, so I realized my mistake. So in any case, now we can use either the sine or the cosine to determine what our angle is. So this is saying that this cosine equals cosine of theta equals 2 all over negative square root of 29, and sine equals, well, it'd be a negative 5, so over a negative is a positive 5 over square root of 29. Now, one thing to think about here, we need to think about where our angle's at first. Because cosine is negative and sine is positive, where is the only place that happens? Well, here sine is positive, cosine is positive. Here sine is positive, cosine is negative. Down in this quadrant right here, quadrant 3, cosine's negative, sine's negative. Down in quadrant 4, cosine's positive and sine is negative. So we got to figure out what quadrant this is in first. So where is cosine negative and where is sine positive? Quadrant 2. Our angle's in quadrant 2. And why is that important? Because I can show you here. Let me pull up my calculator real quick. When we type the sine function into this, we're going to get like 68 degrees, which obviously isn't in the second quadrant. And what that did is it spit out a reference angle, and it's up for us to find the rest of it. So if I were to type in the sine inverse, if I were to type in the sine inverse, let's go to trig here. sine inverse of, I think it was 5 divided by the square root of 29. We're going to get, well, I'm in radians. It changes degrees. We're going to get 68.19 degrees. Well, that's not in the second quadrant. How could we find that? Well, we know from our trig that any angle we find, the reference angle is going to be the same, has a same trig value. So like 30 degrees, the sine of 30 degrees has the same as the sine of 150 degrees because sine's both positive in both the first and second quadrant. So if you notice, 150 degrees has a reference angle of 30 degrees, so the reference angle is always the same as the actual angle in the first quadrant. So all we do is we go 180 minus this guy because we know it's in there. We want to know its reference angle. All right. If it was in quadrant 3, we'd go 180 plus. If it was in quadrant 4, we'd go 360 minus. All right. And here, that gives us our angle right there. So 111.8. Let's go back to it here. So our angle here is 111.8. And the bottom of the thing to take away from that is that you need to figure out, by reading the signs of what cosine and sine is, you need to figure out what quadrant it is before you decide. You can't just type in your calculator because sometimes that'll be wrong. All right, let's do one more problem. One, because I could have been confusing there, and then two, just to be sure if you got it that first time. Now we'll be sure here. Okay, so write the equation 2x plus y minus 5 in normal form. Then find the length of the normal and the angle of the positive x-axis. All right, so to get this to go from normal, or to go from standard to normal, we divide everything by the square root of a plus b, and it's plus or minus, and that sign depends on what this is. It's the opposite of this. So this is a minus, so we're going to have a plus over here. So it's going to be the positive square root of 2 squared plus 1 squared. 1 is in front of the y. So we have the square root of 5. Okay, so we got to divide everything by that. So 2 all over the square root of 5x plus 2 all over the square root of 5, or sorry, 1 all over the square root of 5y minus 5 all over the square root of 2, or wow, square root of 5 equals 0. If they want to know the distance, remember our equation is cosine of theta times x plus y times the sine of theta minus p equals 0. This is already a minus. We want to know what p is, which is perfect. So p is, we don't have to change it. So p is 5 all over the square root of 5. If you wanted to get rid of that square root in the bottom, you can multiply by the square root of 5 on both the top and the bottom, and you'd get just the square root of 5, because this would be 5 times the square root of 5 all over 5. The 5's would cancel out. That's our distance right there from the origin to our normal line. And then to figure out our angle in which it makes, let's see, it says that the cosine of theta equals 2 all over the square root of 5, and the sine of theta equals 1 all over the square root of 5. And where did I get that? I got it because I pulled it right from here. That is the sine in our equation here. That is the cosine of our equation. So we got to figure out when is cosine and sine positive and what quadrants. It's quadrant 1. They're both positive. Okay, so these angles are in quadrant 1. That way we don't have to worry about changing anything. All we need to do is type into our calculator either the sine or the cosine. It doesn't matter. So let's type in cosine. We want the cosine inverse of 2 divided by the square root of 5. Make sure my calculator is in degrees this time. It is. Spit it out as 26.565 degrees. Whoops. I just ruined that, but it was, the angle is 26.565 degrees. Okay. Hope this helps. We'll see you in class.